Recall previously we have defined regular submanifolds, and then we wanted to give some examples of regular submanifolds. Now one class of examples come from LevelSet, i.e. fiber over regular value. So in this video we are gonna discuss regular LevelSet theorem, which basically says that the fiber over a regular value, under a smooth map, fiber under a smooth map of a regular value is gonna be a regular submanifold of the domain. So let us first discuss what is the regular value. And note that there's a distinction between regular points and regular value. Regular points are in the domain and regular values are in the codomain. So a point P is a regular point of smooth map F if the induced map on tangent space at P is surjective. Otherwise, the point P is called a critical point. So for example, in this picture, these green points are critical point because under this map F, the tangent spaces of these points just maps to 0. So it's not surjective onto the tangent spot in tangent space. At the image in the domain should be this whole line R, but the image of this tangent space is just 0, so it doesn't surject this. Now a critical value is a point in the codomain that is the image of some critical point. Note that that doesn't mean it couldn't be image of some regular point. It could be the image of some regular point, as long as if it's the image of at least one critical point, then it's a critical value. And any point in the codomain that is not a critical value is called regular value. So in particular, it doesn't even need to be in the image, right? Then it's just vacuously not the image of any critical point, so it's going to be a regular value. But if it is the image, then it has to be image of a regular point. In other words, for a regular value, all of the points in its fiber must be regular, but its fiber could be empty, in which case the statement is still true because it's vacuously true. So for a critical value, the point in its fiber does not all need to be critical, just one point in its fiber need to be critical. But for a regular value, all points in its fiber must be regular. So let's talk about the regular LevelSet theorem. Here we suppose that we have a smooth map from N to M, and suppose that C in M is a regular value of this map. That means, again, that every point at every point in the fiber here, we have a surjective map on the tangent space. This is a tangent space in N, not just a tangent space in the fiber. So for every point P in the fiber over C, dF at P should be a surjective map on the tangent space. It is the surjection from TPN to TCM. Then we claim that in that case, this fiber over C, which in manifold theory we often call the level set, this level set has to be a regular submanifold of N. Okay, so let's prove this. Now our first remark is that we can combine this with a chart into Rm, right, and center at C, mapping C to 0 here. And because being a regular submanifold is a local condition, if we can prove it in this case, that will imply the proof for the general case. So without loss of generality, we can assume that this M is actually Rm, and C is just the origin in Rm. Now let's take some point P in the fiber. We want to reinterpret the condition that this map here, this differential, is surjective in terms of coordinate matrix. So let's pick some local coordinate xi in this around P. Then the map of this differential map, this dpf, is just going to be given by this. Now for this map to be surjective, we need this matrix to have rank m. So it must contain an invertible m by m submatrix. So by reordering the xi, we can assume that it's this part, right? This invertible. Now the key idea here is then we can replace x1 xm with f1 fm and get a different coordinate chart on n. Now in this coordinate chart, what's the image of this fiber over 0? Well, let's say P lie in this fiber, then its image under this map, it's just, so this part of it, this is just f of P, which is by definition of P, this is just going to be 0 because P lies in the fiber over 0. So this whole fiber is cut out by these coordinates. The idea is that this fiber is cut out by these functions f1, fm, right, because they are the 0 set of these functions. And to turn it into a regular submanifold, we just turn this into coordinate functions. So now the only thing we really need to show is that this actually gives coordinate function. But what does it mean for these to give coordinate functions? Well, we want to show that these maps give a local homeomorphism, diffeomorphism, into a open subset of Rn. And to do so, via the inverse function theorem, it suffices to show that the Jacobian of this is invertible. But the Jacobian matrix of this is just this green matrix here on top. This is a block diagonal matrix, an identity here, because here we're differentiating the xm plus 1 here with respect to themselves, right? And on this corner, we're differentiating these with respect to these, so it's all 0. Thus, this matrix is invertible, and so this map is a local homeomorphism. So this gives local coordinate in which these functions, these coordinate functions, vanish on this whole level set, and so this level set is a regular submanifold. It's cut out by these coordinate functions. So we see that regular level sets are regular submanifolds.